Alright, Chapter 6 Summary. Now that you have completed the chapter, let's review the next concepts and ideas that you have learned. You should have the following understanding principle before moving on. Chapter 7, the fiber optic trend, the hydroelectrical optics device that converts electrical signal into optic signals, launch of the optical signal, the optical fiber, the optical source that converts electrical energy current within optical engineering light with the principal light source with the fiber optic semiconductor light emitting diodes and laser devices. Semiconductor emitting current light who has a fixed phase relationship that are referred to as the coherent light. Semiconductor LEDs emitting incoherent light with the fixed phase relationship are referred to as incoherent light. Relevant optical power amount with the optical power coupled into the fiber, the percent of the angle over the light emitted with the side of the source of the light emitting area relative to the fiber core side of the lining with the source of the fiber, the coupling character of the fiber, show the numerical armature of the reflective index profile, source of the fiber, coupling efficiency measure for the relevant optical power. Silicon and gallium arsenide are two most common semiconductor materials. Electronic and electrical optic devices in semiconductor photon lights are emitted with the current flow through the active area of the spontaneous emission curve of the photons are removed with the random manner or spontaneous emission produced the incoherent light. Simulated emission that occur with the photo interactive laser materials to produce additional photons. Light emitting diode semiconductor devices that emit the incoherent light through the spontaneous emission for the current of the path through it. The light because the basic light emitting diodes use the fiber optical communications of the emitting light diode, edge emitting light diodes, and superluminescent diodes. Surface light emitting diodes side of the primary active region limited to the small circle of 20 to 15 millimeters in diameter. The active region from the portion of the LED where the photons are emitted. The surface light emitting diodes usually emit more total power with the air gap of the fiber interface with the edge light emitting diode. The unit launch much more power than the fiber. The super light emitting diodes also tend to emit the power over the wider spectral range of the edge light emitting diode. Or your edge emitting LEDs emit like narrow dimension angle along their source of fiber connection, couple the power into the numerical armature fiber. The surface of the lighting emitting diode, the polish cover the surface of the edge end of the edge light emitting diode. Active stripes called the facets. Superluminous and the curve of the spontaneous emission of the edge light emitting diode expansion gain with the high injected current of the reflection for the facets. Superluminescent diodes are similar to the geometry laser. They have no built-in optical feedback mechanism required. Laser devices stimulated emission when achieving the laser, although the output is not fully coherent. Superluminescent diodes emitting consistently amplified spontaneous emission spectral with the beam angle of the surface. Superluminescent diodes are narrower than that of the conventional LEDs and wider than the laser devices. Advances in superluminescent diodes over conventional LEDs include the higher power, narrow spectral width, with greater bands. The disadvantages include nonlinear power current character with the high power temperature sensitivity, lower reliability. A laser is a device that produces the optical radiation using the simulated emission rather than spontaneous emission. The laser acronym is light amplification stimulated emission radiation. Lasering threshold, lowest drive level at which the output of the laser result of the primary stimulated emission rather than spontaneous emission. Threshold current, lowest current through the stimulated emission C with the spontaneous emission laser diode semiconductor diode that emits the coherent light by lasing the LED device. Output has a narrow spectral width and a small output beam angle. The transmitter output interface falls in two categories: optical connectors, optical fiber pigtails. Fiber optical transmitters using the laser device require more complex circuitry than transmitters using the LED because the laser device, the threshold device, the laser device is supplied with a bias just below the threshold in and off of the state. The bias is often referred to the pre-bias. The least complex fiber optic transmitter typically packed with a transistor, unlike can be hybrid microcircuit with a dual inline package. Most complex fiber optic transmitter typically in the package hybrid microcircular mods with a dual inline package butterfly lead package with the circuit card with a complete standalone fiber optic converter. Fiber optic transmitter can be classified in two categories: digital and analog. Digital transmitter mode, the fiber optic source between the two discrete optical power levels is essential on and off the consumption of the some of the light limited to the on-off state with some of the transmitter. Analog transmitter can continuously vary with the optical output power level of the function of the input electrical energy. For low data rate applications of 0 to 20 megabytes per second, fiber optic transmitter generally use the LEDs operating either at 850 nanometers or 300 nanometer window. Moderate data rate application 50 to 200 megabytes per second fiber optic transmitter generally the LEDs operating at 1300 nanometer window. High data rate applications most fiber optic transmitters the light laser diodes as source. Laser sources also must never use low or moderate frequency analog applications because the LED source requires much less complex circuitry. And that was Chapter 6 summary. Moving on to Chapter 7, optical detector fiber optic receivers.